So in order to find the volume of a 60-piece star, we're going to have to divide it up into shapes that are more familiar to us, that we know how to find the volume of. So the way you can approach this, the 60-piece star has 30 kind of pyramid-like spikes. And you can think of the base of all these pyramids, if they were to have bases, as being rhombuses, because all of these sides are the same and the sides are parallel and all of that. And there's actually a 30-sided polyhedron which has rhombuses as all of its faces, and so I'm thinking that the center, underneath all these spikes, say if these spikes were to be flat on the bottom, then you would have that shape, which is called a rhombic tricontahedron. And if you look at the two different shapes, you can see that there's some similarities. Like right here you have 5 rhombuses coming from this kind of corner here, and it's the same here that you have 5 spikes coming off. But then in some areas you have 3, like right here and right here. So I was thinking we could find the volume of that inner rhombic tricontahedron in the 60-piece star, and then we could find the volume of one of these little pyramid spikes and then multiply it by 30. And then if we add those two numbers together, we can get the total volume. So we have all these equations for the rhombic tricontahedron. The volume is the side length cubed times this ugly number. So that means we just have to find the side length, which is going to equal this length in here, this kind of inner kind of line right here, which, if you think about it, is this. If we just look at one spike, it's this side length. That's going to equal A, which is the same as this side length. So I already have the dimensions from when I did the surface area video of one piece, and I marked with a marker on a piece of paper this side length and found out that it's this little length right here. Similarly, I looked at the height and found out that the height is also this side length. So using the Pythagorean Theorem, we can easily find this side length, and it's root 2 over 4s, where s is the original side length of the piece of paper. So we have x equals root 2 over 4s, which means that that's the side length of this little rhombus. That's the base of this pyramid. So the volume of the pyramid is going to be 1/3 times the base times the height. We already have the height, that's root 2 over 4s, it's the same as the side length right here. But we need to find the area of the base. And we know the base is a rhombus with side length root 2 over 4s. But we still need an angle measure in order to solve for the area. So in a rhombic tricontahedron, the rhombuses all have an acute angle of 63.43 degrees. So if we use that side angle, we can find the area. So then we get that the area of that rhombus is 1/8 s squared sine 63.43 degrees. So that's the area of the base. So then we plug that back up here. So then you get that the volume is root 2 over 96 s cubed times sine of 63.43 degrees. So then we multiply this by 30. And we get, so then we get that the volume of the 30 spikes is 5 root 2 over 16 s cubed sine 63.43 degrees. So So we'll come back to this once we find the volume of the center. So back over here, the volume is the side length, which we already found. So that was root 2 over 4 times 4 root 5 plus 2 root 5. This is cubed. So then you get root 2 cubed over 64 times 4 root 5 plus 2 root 5. So when we simplify that, I'm pretty sure we get the square root of 10 plus 4 square root of 5 over 8 s cubed. So then we can add the two numbers together. So what do we have up here? We have 5 root 2 over 16, 5 root 2 over 16 sine 63.43 degrees. Is that what it was? 63.43, yep. Plus square root of 10 plus 4 square root of 5 over 8, and all of that times the original side length cubed. So that's pretty ugly, but hopefully that's pretty close to the actual volume of the 60-piece star.